Good evening, students. As per suggestion of our principal, sir, Mr. A.K. Jana, DAV Public School Work, sir, we have started online classes due to national lockdown in this time or period. We have started online classes for class 12 especially, and hope you all support me or us with full energy as you always given inside the classroom. Now I am going to start the first chapter of electrostatics of class 12. Electrostatics is the first chapter of class 12 of subject physics. Actually, the first question in our mind, or I hope you also think about the chapter. Why this chapter? Then answer of this question is the chapter or the human nature always curious to know to explore the natural phenomenon of nature, as like lightning, thundering. These are natural phenomena. This phenomenon is explained by the concept of electric charge. And the machines, there are so many machines are working on the basis of this chapter. The first machine is Xerox. First means not the first. First means the serial number 1, Xerox machine, photocopier. And next is capacitor, very important. Without capacitor, in past time, there is no chance to click the photo, and so many works. Condenser is other name of capacitor. Fan is also rotated due to the capacitor in AC current, not DC, AC current. And Van de Graaff generator is a electric potential difference created or maintained up to the lakhs volt, many lakhs, not lakhs, many lakhs volt, Van de Graaff generator. And the other uses of this chapter maybe explain the spray painting, powder painting, and so many devices working on this concept. Then the chapter is very important for 2 points of view. One is your academic, and other is to explore the nature or machinery. Then our first question is, I think, explain. And the second thing is the electrostatics. Electro means charge and statics means rest. Means the chapter explain about the charge which is kept at rest. Means when a charge is at rest, then what circumstances created by this charge, influenced by the other body, other charged body or neutral body, these all are explained according to the law of electrostatics. The first point, topic, concept we will discuss here, charge. The biggest term is charge. This is the charge. I have written so many information on the board because of the sake of time. Charge means charge is topic and subtopic are so many. Definition: what is charge? Nature of charge, polarity of charge, neutral body, what is neutral body? A scalar, what is the function of a scalar? Unit conversion factor, quantization of charge, conservation of charge, transfer of charge, charge distribution or density, quark concept, and so many numericals on the basis of the charge. The first thing is, what is charge? Actually, the absolute definition is not needed because it is a fundamental particle and the charge is not a particle. Yes, I know you know about the electrons. Electrons and protons are particle, and this is the charged particle. Electrons and protons itself is not a charge. That is why charge. What is charge? Then the first thing is, charge is the intrinsic property or characteristics. Charge is the intrinsic. Charge is the intrinsic property or characteristics of any body. What do we mean by the intrinsic? Intrinsic means inseparable. Inseparable means we cannot separate the charge. We cannot separate the charge from any body. Okay? Means intrinsic characteristics of any body. Then what is the function of what behavior? So after the introducing the charge, due to the charge, we can easily explain the conductor, which material is conductor, which material is insulator, and which material is semiconductor. Which material is semiconductor? Means a material which can allow the flow of charge is called conductor, which does not allow to flow the charge is called insulator, and which has the property between conductor and insulator is called semiconductor. Semiconductor means silicon, most commonly known, and germanium. Most common examples of semiconductor, silicon and germanium. And insulator is rubber, just like wood, also wood, plastic, also insulator, plastic, insulator, air. Air is very good conductor. And conductor is metals, mostly metals are conductor, metals alloys anyway. The one thing is here I want to discuss. Insulator word is air is insulator, as you know, a very insulator as per heat and also electric charge. Air is very good insulator. But after the rain, lightning comes from a sky to the earth via the air. This is very surprising. Because air is bad conductor, but at that time, air is conductor. Then you want to say, just I imagine, sir, air is conductor because there is moisture, and that's why air is conductor. Okay, very good. But the electricity line is not conducted in air at the same time during the lightning. Why? Because in your queries, lightning comes from a sky to the earth due to the moisture. Then electric current flowing in a wire and just conduct to the air, but it is not true. Just you see every day, yeah, every year. Anyway, their insulator word is not appropriate in my view. Insulator is insulator until the potential difference is not given too much high value. Means the potential difference decide charge can flow or not. Okay, and after the discussing potential difference, then I will again discuss on this topic. And the next thing is, on the basis of charge, we are going to explain conductor, insulator, and other is the semiconductor. Then I think the definition is over. Charge is an intrinsic characteristics of any body, means inseparable, due to which, the extension of this definition is due to which we study about electrical behavior of matter. Electrical behavior of matter, of body, anyway. In physics, body is most common, that's why it is body. And now the nature of charge. What is the nature of charge? Somebody knows. Nature means Benjamin Franklin, as written here, Benjamin Franklin. Benjamin Franklin noticed that when one body is rubbed on another body, then one is charged and other is oppositely charged. It means Benjamin Franklin gave the name, one is positive and other is negative. And some other scientists just arrange the substances as this. The first is fur, and second is funnel, and third is glass. Third is glass, double S, glass. Means if fur is rubbed with the glass, then glass is negatively charged and fur is positively charged. Suppose that fur and PVC, or cotton and PVC, when rubbed with cotton and PVC, then PVC is negatively charged and cotton is positively charged. As in the series you are also studied in chemistry, chemical series, okay, electrochemical series, and that is the charge series. The top is fur and bottom is PVC. And the one word is perspex. Perspex is a polymer. Actually, perspex is the polymer. Polymer is some methyl group, and anyway, just like a polymer glass, you can say it. Perspex. And everyone you know. Wax is known by you. Wood is known. Leather, silk, cotton, glass, flannel. The woolen cloth, something similar to the woolen cloth, and this is the flannel. And the second thing is positive charge and negative charge, given by Benjamin Franklin. And the second thing is Henry Cavendish. Henry Cavendish gave the law of attraction and repulsion of force. Means like charges repel to each other, and unlike charges attract to each other. Okay, like charges repel to each other and unlike charges attract to each other. Means positive charge and positive charge repel to each other, but positive charge and negative charge attract to each other. You know very well about this. Then I think nature of charge is finished. And then third is the polarity of charge. Polarity of charge means the pair of positive charge and negative charge is known as polarity of charge. Neutral charge. Neutral charge means neutral charge. What is neutral charge? A body has no net charge, a body has no net charge, is called neutral body. Is called neutral body. A body has no net charge. It means a body has no net charge means a body has no charge. No, a body has no net charge means a body has equal amount of positive charge and equal amount of negative charge. No net charge means equal amount of positive and negative charge. Okay, I give you 1 or 2 minutes to write this. Okay, now the neutral word is completed, and next is the scalar. As you know, a scalar charge is a scalar quantity. What do you mean? What it does mean? Charge is a scalar quantity. It means you can add it or subtract it algebraically. We can add it or subtract it algebraically. Means algebraically means, okay, I rub it. Means a body has 5 coulomb of charge, plus charge, and some other minus. This one is the plus charge and this one is the minus 3 coulomb charge. The net charge is minus 8 coulomb, but some body has minus 5 coulomb or plus 3 coulomb, means net charge is what? Minus 2 coulomb. Means this body is negatively charged, this body is also negatively charged, but this one is 5 coulomb and 3 coulomb becomes 2 coulomb. 2 coulomb. It becomes positive charge body. This is the positive charge body, this is negative charge body, this is negative charge body. Then the coulomb. What is the coulomb? One thing is written here, coulomb. Okay, and the symbol is capital C. I repeat many times, the unit is written, started with the small letter, but symbol is capital letter, and that's why here coulomb is in a small letter and symbol is capital letter. Coulomb is the SI unit of charge. SI unit of charge is coulomb. Charge is coulomb. COULOMB, coulomb, and symbol capital C. And the CGS unit is ESU of charge. ESU of charge. It is also known as electrostat unit, Franklin, stat coulomb. Everything is written on the board. CGS unit, ESU of charge. And the next thing is practical unit. Practical unit is introduced by the Kinley. Practical unit of charge, EMU of charge. This is called electromagnetic unit. EMU of charge. It is called electromagnetic unit, introduced by Kinley. Okay, in I think 1875 or okay. Then practical unit is EMU of charge. Then the unit is over. And now the conversion factor. Conversion factor means one unit can be converted into another unit. As for example, 1 coulomb is equal to 3 into 10 to the power 9 ESU of charge, electrostat unit, or a state coulomb, or a stat coulomb. It is also known as a stat coulomb. And 1 coulomb is equal to 1 by 10 AB coulomb. AB coulomb or EMU of charge. Then for your curiosity, how many ESU in 1 amp coulomb? You can convert it easily. ESU of charge. Okay. This one is. Then the SI unit is coulomb. CGS unit is ESU. Practical unit is actually this is also CGS unit, but CGS unit where in charge in motion, if charge in motion. Okay. Actually, current is the fundamental quantity in electromagnetism, and that's why ampere and ab ampere or AB ampere is used. As for example, suppose that charge is given 3 coulomb, time is given suppose at 1 second, then current is Q by T as you learned the formula in class 10, then 3 coulomb by 1 second is equal to 3 ampere. Okay, this is very simple. But when you used 3 coulomb, or if this is SI, if you convert in CGS, then the coulomb must be converted into ab coulomb, not ESC. Okay, then it becomes AB ampere. This is called AB ampere. Then how it is converted? Then conversion is I is equal to Q by T. Same formula. Then 3 coulomb is equal to 1 coulomb equal to 1 by 10 AB coulomb. Then just 3 by 10 AB coulomb, ABC. Then it becomes 3 by 10. Then it becomes 3 by 10. And this is the ABC, ab coulomb. C is capital letter. Then it becomes 0.3 AB coulomb. This is. Then ab coulomb is sorry. Ab coulomb, not ab ampere. Ab ampere. Here is also ampere because it is divided by the time. That's why here is ab coulomb, right? But here is AB ampere. Here is AB ampere. Ampere is also written in a small letter. Okay, because the unit is started with a small letter and name is started with a capital letter. Okay. Now the next topic is conversion factor is over. Now next topic is quantization of charge. What is quantization of charge? Quantization means quanta. Quanta also used in chemistry due to just Bohr's model, atomic model, and also one thing also in atomic structure, the movement of electron, the revolution of electron explained by the force electrostatic force. Okay, electrostatic force, and on the basis of electrostatic force atomic structure is explained, and all derivations, radius, velocity, and these all energy also, and also the spectrum is defined by the electrostatic force. Okay, and it is discussed in later chapter. Yeah. Okay. Then next is the quantization. Quantization means restriction. In dictionary meaning, quanta means restriction. A restriction means all is not allowed, all is not possible. Means the amount of charge is equal to integral multiple of E. N is the quantization charge is what? The amount of charge on anybody, the amount of charge is integral multiple of fundamental charge particle. This is very important. Not E. Q is plus minus, means the value of E is plus minus 1.610 to the power minus 19 coulomb. This is not electron. maybe you consider electron, but it is not electron, it is a fundamental charge 1.6 into 10 to the power minus 19 coulomb. Means the amount of charge on any body is integral multiple of E. Means suppose you want to purchase something just like a lemon, then you buy it single piece 1, 2, 3, and no one is selling just cut the Nemo. And as same charge on any body, just like charge on any body is complete 1 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6 electron, but never it is half, never it is 1 by 5, and this is the fractional value of electron is not possible. Fraction of electron is not possible. Electron is not possible. This is the quantization. Quantization means electron transfer from one body to other body, from one body to other body, 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, this type of. And this formula is very important. Just for example, also studied in class 10, when 1 coulomb of in 1 coulomb of charge, how many number of electrons exist? They are so simple. Q equal to Ne, then N equal to Q by E. Okay, then 1 coulomb by 1.6 10 to the power minus 19. This is all. This is number. It becomes number. I think it becomes 100 by 16. 100 by 16 into 10 to the power. How much? I think 80. 80. 80. Okay. So then 6.25 6.25 10 to the power 18 electrons. Okay. This will done very easily. This is the quantization of charge. Now conservation of charge. So simple, as you learned many times, conservation of energy in class 9. Here is also conservation of charge. Conservation of charge means a body never created, never destroyed. The two words remember: never created, nor destroyed. Destroyed. It is never created nor destroyed. It can transfer from one body to another body. It can transfer from one body to other body. Conservation of charge is used in chapter nuclei, and it will be discussed in that chapter. Conservation of charge and conservation. Transfer of charge in this chapter. Transfer. There are three methods. The first method is contact, direct contact. With the help of direct contact, means via conductor. Conductor means when one body is connected with the other body, then the charge Q1 and Q2, this one is Q1 greater than Q2, then charge can flow from Q1 to Q2 due to the potential difference. The Q1 has the first body had body A and body B. Body A has more charge, means more potential, and body B has less charge, means less potential. Then this is at high potential electric potential, and this is the low electric potential, and that's why charge flows from this body to this body. The next topic is direct contact. The other topic is frictional electricity. Frictional electricity is the charge transfer by the rubbing. When one body is rubbed with the other body, then one body is positively charged and other body is negatively charged. and that is known as the frictional electricity. Somewhere it is called triboelectricity also. Triboelectricity. Okay. And the third one is very important. Induction. Third one is very important, and induction. It is induction. Induction. Induction is, what is induction? The third step. The third type of transfer of charge. Induction. When a charged body kept, this is the insulating pad, insulating stand, this is neutral body, and step 1, this is a step 1, and the second thing, the second step is this is also insulating body stand, and step 2, this is the step 2. Suppose that one charged rod kept near, not in direct contact, near to the body, then it is oppositely charged. Then 3 charge is here, also 3 charge, and this is the also 3. The step 3 is one charged body and just earthing it. Earthing means you connected to the joint, and this is the charge. Sorry, this is not connected. Plus charge. Okay. Then positive charge goes down and it becomes only, last step and the fourth one is positively charged body, and 3 charge also. Then spread all over the body, and this is the last step, step 4. Means a neutral body becomes negatively charged by the process known as induction. Induction means it is a method of transfer of charge without actual contact. In equal amount and opposite in nature. In equal amount and opposite in nature. It is. This is the most important transfer of charge over. Now the charge distribution or charge density. Charge distribution